As soon as the segmentation procedure is finished, we will be able to find the files with different segments of the brain tissue. All of them are located in the subfolder structural. There will be prefix C1, which is for the gray matter, C2, which is for the white matter segment, C3 for cerebrospinal fluid segment. Here in the picture you can see an example of the gray matter segment image. And there will be a bias corrected structural image. Using the function checkReg, we will be able to compare all of them and to see if the segmentation worked well. Let's go to SPM, click checkReg, go to structural and select C1, C2, C3 and MS files. 4 files in total. Click Done. Here you can see 4 images, and by navigating them you can figure out if the segmentation worked well. For example, you can click on corpus callosum and identify clearly that there is some white matter tissue identified, but definitely no gray matter tissue. Or you can go to the ventriculus and you will see that there is no gray matter, no white matter, but for sure the CSF is identified. Other way to check if all the images correspond well to each other is to use the reorient image option, which will project the contours of the current image to the other images. And it is pretty obvious that our segmentation worked well. And we get exactly as expected. Let me remind you that C1 is for gray matter. You see the cortex and thalamus, caudate, the white matter, C2, and C3, CSF. There are other tissue classes, but we will not review them specifically. The next step is normalization. And we will have to run normalization for functional images and for structural images. For structural image, since we have only one structural image. This procedure is necessary to fit the shape of the functional images and the structural image to the canonical average MNI template. We click on Normalize Right in the SPM menu window. For data, you select New Subject and you highlight Deformation field and select the file started with Y and stored in structural folder. This file is created at the stage of segmentation. Then you highlight Images to Right and you select all the reoriented, realigned functional images. Then in the section of the module Writing Options, you modify slightly the bounding box. Those two last numbers must be different so that all the brain is well included in the resulting file, and you indicate the voxel size, which is 3 by 3 by 3 millimeters, and this corresponds to the acquisition parameters of the functional scans. At the end, as usual, you save the batch file as normalize functional and click Run. Let's do it together in SPM. You click Normalize Right. We don't need to estimate the deformation parameters because it is done at the previous stage. New Subject, Deformation field, specify structural folder, and here it is. Done. Images to Right. You go to functional and you set the filter properly. Everything that starts from F will be separated by this filter. You right click on the list, you select all. You must have 84 files as usual. Here is the indication that you have 84 files. You click Done. Bounding box, we modify the last two numbers to increase slightly the special restrictions of the image, of the resulting image after normalization. This is very important. The size of the image will be modified by the normalization procedure, and those are the limits in x direction, y direction, and z direction. 80 and 90. Okay. And voxel size 3 by 3 by 3 millimeters. Okay. Now we save it to jobs as normalize. Functional. And we run it. Normally it works pretty fast. Here you see the indicator of the progress. I think it is done. And we can use check range to see if the normalization worked well. You go to functional. Now you indicate in the filter W. This prefix stands for normalized images, or warped. You select just one image. Then you go to SPM12, folder canonical. No filter is needed. You select average 305. You click done. And you see that now those two images fit each other very well. This means that our normalization is successful. The size and the shape of the images are quite similar. Acute reorient mode. And now we have to do exactly the same for the structural image. The structural image also has to be normalized using the same deformation field. But for images to write, instead of many functionals, you select just one structural image, which is a bias corrected image. The bounding box is the same, but the voxel size is different. There will be smaller voxels, stretched vertically. We pick this option because it was the resolution of the acquisition of structural images in this particular case. And then you save the batch as normalized structural and run the procedure. Let's do it together. We can use the same job module as we used for the functional images. We just have to unselect all the functionals. We go to the structural and click on MS. Done. And we modify the voxel size. Don't forget to save the job. And run it. It is done now. Let us see if the structural image is well normalized. We pick the normalized structural image that now has W prefix, and we pick the same canonical template. Click Done. And to be sure, let's project the contours of the normalized structure onto the template. As you can see, in this case, the shape of the brain after normalization fits very well the template. So the normalization is finished, and we can go to the next step, which is smoothing. This slide illustrates how the normalization procedure changes the shape of the structural image. On the left bottom, you see the original structural image and the projection of its contours on the template, and on the right, just what we have seen a few moments before. What you can also do to be certain that your data are consistent is to compare the correspondence of your structural and your functional image before and after normalization. Normally, they should correspond both before and after. And the next step is smoothing, which will be described in the next part.